making the solution, we have a solvent, which is the dissolving medium, the substance that we're going to dissolve a substance in, and we have the solute, which is the substance that's being dissolved. In this instance, I'm going to make a solution out of sodium acetate and water. Now, every substance has a certain solubility at a given temperature. And at room temperature, sodium acetate, I should be able to dissolve about a little under 32 grams of sodium acetate in the water that I have in the Erlenmeyer flask right now, which is about 37.5 milliliters of water. That would give me a saturated solution. In doing that, that means that there should be enough room in this Erlenmeyer flask for me to dissolve all or most all of the sodium acetate that I have here. Now, in a saturated solution, I may have some undissolved salts floating around in there, but that undissolved sodium acetate is going to be at equilibrium with the dissolved sodium acetate. In other words, there might be a little bit sitting on the bottom of the flask that is not dissolved. That means there's no more room in the water for the water molecules to move apart and finish solvating the sodium acetate that I have in the flask. Now, sodium acetate lends itself to making what we call a supersaturated solution, which means I am able to dissolve more solute in my water, in my solvent, than should be theoretically possible. And sodium acetate lends itself to forming the supersaturated solution pretty easily as long as we heat up the water, the solvent. Now, the higher the temperature of the water, the greater, and this is the case for many salts, the greater the temperature of the water, the more sodium acetate I will be able to dissolve. And so I'm actually going to add quite a bit more sodium acetate to the flask in order to try to create a supersaturated solution. Okay, well, I don't know. That's an awful lot of solute trying to dissolve in that flask. But we'll heat it up for a little while and see, once we get it nice and hot, how much of that sodium acetate is actually going to dissolve. When making the solution, we have now the water has been brought up to a boil, and it looks like all of the sodium acetate has dissolved, and I've created a supersaturated solution here, and supersaturated solutions are very unstable. In theory, if I were to cool this down, all of that extra dissolved solute should fall out of solution. But in a supersaturated solution, what makes it different and unique is the fact that all of the solute stays dissolved when, in theory, it should not. So it is very unstable, and sometimes just a little bit of movement is enough to make the substance crystallize out. But what we'll do now is allow the substance to cool, and as it cools, if the solution stays in the supersaturated state, none of the salt will fall out of the solution. So we'll give it some good time to cool slowly and then see what happens. Okay, so we have a supersaturated solution here. We got all of the solute to dissolve in the water when we heated it up, and I've since let it cool for a few hours. So what should happen is, since it's supersaturated, since it's really unstable, since there's a lot of solute sitting in there right now, waiting to crystallize out of that solution, if I add just one little crystal, which is called a seed crystal, although I have a really big chunk in here right now, if I add one little seed crystal to that solution, the whole thing should crystallize out, and here we go.
Swoosh! Did it do it yet?
Can you not see it?